Legacy XOOPS blocks relied on disorganized procedural code, managed through monolithic 500-line files. XMF 2.0 replaces this entirely with a unified, object-oriented widget system. Step 1 is outlining our objectives. We're building a component that fetches data, restricts user access, configures instant cache invalidation, and establishes multiple visual variants. We will achieve all of these capabilities by utilizing modern PHP attributes. This approach completely eliminates the need to write repetitive plumbing and boilerplate code. Mastering this attribute-driven architecture replaces 4 disconnected legacy systems with a single, standardized development pipeline. Let's start the foundation. Create a new PHP class in your module that extends abstract widget and implements the widget interface. Above your class declaration, add the @widget attribute. Including the API true parameter here triggers auto-discovery and instantly enables REST API access. A REST API is a standardized interface that allows external applications to request and interact with your data over the web. Next, we handle dependencies. Use constructor injection to bring in required services, like your database repositories. This ensures you avoid using global state entirely. Finally, you must implement the getData method. The strict role of this function is to exclusively fetch and return raw array data for the rendering pipeline. By strictly preventing any business logic from entering the getData method, you guarantee that the widget remains a pure, highly testable data provider. With the data fetching in place, we can apply attributes to control performance. Add the @widget_lazy attribute to render heavy widgets asynchronously. This instantly outputs a lightweight UI placeholder on initial page load, fetching the real content in the background. For static access control, apply the @widget_visibility attribute. You can specify user groups here, restricting the widget's rendering strictly to members like webmasters. If you need dynamic access control, you can override the isVisible method directly within your class to enforce specific instance-level logic. To manage caching, introduce the @widget_cache_tag attribute. This permanently ties the widget's cache data to specific domain events. This diagram shows the exact cache key formula. The string breaks down into 4 distinct variable components: the widget name, variant, and an MD5 hash of its sorted properties. Changing a single property creates a mathematically unique cache entry. When a system domain event occurs, such as a new post being published, an event bus listener targets and instantly invalidates all widgets carrying that specific tag. These declarative attributes replace hundreds of lines of manual cache management and permission handling logic. Now we apply visual options to our data. Introduce the widget variant attribute to define multiple visual styles, such as a list view versus a grid view, for a single widget's data. Variants allow you to declare targeted CSS assets. This ensures the browser only loads the specific styling code required for the currently active variant. To render the final component on the front end, use the Smarty tag syntax. Smarty is a template engine for PHP that cleanly separates your application logic from your visual presentation. This downward flowchart illustrates the template resolver cascade. The system uses a strict descending order to find the correct template file, checking for a theme override first, then a module template, and finally the framework default. A developer can override a widget template simply by placing a custom.tlp file directly into their active theme directory. Variants and the template cascade strictly isolate the underlying data logic from the final visual presentation. This hierarchical tree diagram displays how the widget composer builds nested page structures. It establishes parent-child widget relationships, allowing a parent wrapper node to contain multiple elements, like 1 header child and 3 stat card children. To manage these layouts across an entire site, use the Widget Area Manager. This defines and organizes persistent layout slots, like your sidebars or footers. You render these predefined layout slots globally in the theme using the @widget_area Smarty tag. This architecture also supports a theme designer's workflow by offering a JSON manifest alternative to PHP classes. JSON is a lightweight data interchange format that is easy for humans to read and write. Theme designers construct a widget.json file and link it directly to a .tpl template, requiring absolutely zero PHP logic. These JSON manifest widgets natively inherit the exact same caching, permissions, and API pipeline as the PHP-based widgets. The widget composer and JSON manifests bridge the gap between back-end logic and front-end design inside one unified architecture. The final user experience features a page that loads instantly. Heavy widgets lazy load in the background, and live domain events trigger instant content updates. This robust result is achieved with zero boilerplate code, yielding a fully cached, strictly permission-controlled, and API-ready component. This single widget system empowers both PHP module developers and JSON-focused theme designers equally. Consult the official framework documentation to explore the full list of available attributes and begin building your first unified widget today.